Welcome to the last lecture of this course, Lecture 12, Advanced Topics and Applications. In this lecture, we are going to discuss some advanced topics, including clustering data streams. We will first introduce a k-median-based approach. Then we will introduce the clustering approach. After that, we will briefly list some advanced themes of cluster analysis. Then we will introduce some applications of cluster analysis. We'll discuss name disambiguation using cluster analysis method. And we also discuss how to mine evolution of heterogeneous networks using cluster analysis methods. After that, we will briefly introduce some exploration of broad applications of cluster analysis. That will conclude our course. First, we will discuss clustering data streams, a k-median-based approach. What are data streams? Why they are so important? We want to discuss it. Actually, data streams are very popular in current big data age because there are lots of sensors or video cameras and many other things. They actually record data in the online data stream version. That means the data were flowing in to your video camera and flowing out. You may not register everything, okay, especially in those observation systems. The major feature is they are continuous, ordered, keep changing, they come in and go very fast, but in huge volume. With such fast data streams, a very important requirement for the algorithm is the single scan. That means you're not going to have time or chance to store all the data and keep indexing and also try to access in a random way. You basically get a scan, you want to reply them in real time. So here is a typical stream processing system architecture. So we are facing multiple data streams, they flowing in like those observation systems. Then the system will take those multiple data streams, will process this one in some scratch space, like main memory or some disks as well. Okay. Then in the meantime, users or application programs usually post query in the form like a continuous query, in the sense you have a request. You say, alarming me when certain situation happens. Okay. Then the stream processing system, taking these multiple online data streams, will try to return the results to check the query return results in the real time. Then the problem becomes, how can we perform cluster analysis effectively in such fast-changing data streams? One proposed approach for stream clustering is a k-median-based approach. This method was published in ICDE 2002, done by O'Callaghan and several other researchers. This method is based on the k-median method. That means the data stream points coming, they are in the form of metric space, so you can easily compute medians. The goal is to find k clusters in the data stream such that the sum of the distances from the data points to their closest centers is minimized. So the whole thing is similar to what the requirement of typical clustering algorithm. Then, because it's a data stream, so usually this method actually designed in a way like a constant factor approximation algorithm. It uses a reasonably small memory space. It's a simple two-step algorithm. That means for each set of M record, like a S sub I, you're not going to register all those M records because it's flowing in very fast, potentially infinite. Okay. But we try to find OK centers in the stream, like a S sub 1 to S sub L. This OK means usually you want to find K centers, but you want to store multiple case. Okay. It's a local clustering. That means you want to assign each point in S sub I to its closest center. Let S prime be the centers for this currently, with each center weighted by the number of points assigned to it. Simply says, these points, you only register points, but you also register weight, because this point actually could be summarized by many online data stream points. Then we take this S sub 1 to S sub L, these centers. Then we will try to use this S prime to do further clustering to find K centers. So we can draw a hierarchical clustering tree. We can illustrate the method. Okay, the method is we see many data points, but we do not have capacity to keep storing all the data points. What we want to maintain is at level I, we will maintain at most m level I medians. That means we only maintain the median points and also the weights. That means how many points really, aggregated. Finally, you only register medians. Then if we see m such medians coming, we will generate one more level. This level, essentially level I plus 1, is still case multiple. Okay. But the weight is equal to the sum of the weights of those medians. That means if you look at the level I plus 1, this median point, the weights, essentially means how many points it really represents is the sum of the weights of level I medians. And level I medians is the sum of the weights of how many real data points actually is summarized and represented by this median point. So it works, but the problem could be the quality may suffer for evolving data streams, because when the data streams keep coming, if you only register the m level I medians, in many cases it may not be sufficient, and you do not know whether what you register are very old points or just very recent points. Then you will provide limited functionality for discovering and exploring clusters over different portions of the stream over time. Okay. So that's the major thing. We probably need a more robust and more sensitive clustering method.